The company has developed blood substitutes from bovine blood, Hemopure for the human market and oxyglobin for the veterinary market. Oxyglobin is the first blood substitute for the veterinary market, and Hemopure is expected to be approved by the FDA in 1999. BioPure's annual production capacity is limited to 300,000 units of oxyglobin or 150,000 units of Hemopure, or a linear combination of both products. However, production is limited to one product at a time. 1995, 85% of veterinary practices use donor animals to supply blood, with veterinary blood demand approximately 355,000 units. Primary care veterinary practices charge pet owners between $80 and $120 per unit of blood, while emergency care practices charge between $130 and $170 per unit. Distribution costs for oxyglobin through established distributors are 30% of selling price, and distribution through the manufacturer's sales force is between $10 and $15 per unit. As a rule of thumb, vets tend to double the price of medical products to the pet owner. For the human blood market, Hemopure's demand is 14 million units per year. Hemopure's price range is anticipated to be between $600 and $800 per unit. Currently, there's no competition in the veterinary blood market, but there are two competitors in the human blood market: Baxter International and Northfield. Oxyglobin has passed the core competency test. By eliminating the costs associated with blood donations, oxyglobin provides a better value proposition than the products currently used in the market. Oxyglobin is the only product of its kind, and it will take 2 to 5 years for a new entrant or an incumbent to develop a competing product for this market. Being essential to saving human and animal life, both products, oxyglobin and Hemopure, offer many valuable benefits. The source of differentiation for oxyglobin as well as Hemopure is that both products do not require refrigeration. By providing additional benefits over current products, oxyglobin's entry into the market is made possible. Oxyglobin and Hemopure utilize the same raw materials and an almost identical production process. Supply of bovine blood is $1.50 per unit compared to Baxter's $8 and Northfield's $26. Additionally, bovine blood is more readily available than the outdated human blood used by BioPure's competitors.
BioPure needs to make a decision on the timing and strategy of the oxyglobin launch in order to maximize profitability of oxyglobin while considering the effects on Hemopure. Some of the key points from our analysis include BioPure's competitive differentiators, which include having the only FDA-approved blood substitute on the market and the bovine base of their product. Also to BioPure's benefit are the entry barriers imposed by the FDA approval process. This prevents competitors from entering the veterinary blood substitute market or switching to a bovine-based blood product. Challenges to BioPure's success include their limited factory capacity. This is amplified by their leading competitor's factory capacity, which is more than 3 times the volume of BioPure's veterinary product capacity and over 6 times their capacity for the human blood substitute product. The optimal price point for oxyglobin was found by evaluating the demand and adjusting the price accordingly. Demand and 4 price points were given in the case. These prices were $50, $100, $150, and $200. The assumption was made that being the only blood substitute on the market, we would be able to capture 50% of the calculated demand. This resulted in demand shown in Table 2. This table shows that at a price point of $150 per unit, the demand for oxyglobin is significantly greater than the 300,000 unit capacity of BioPure's facility. Also, the $200 price tag shows a demand that is significantly less and does not fully utilize BioPure's production and revenue potential. When the 4 price points are plotted, they appear to have a linear relationship. When a line is fit to these points, the equation becomes y equals negative 11,745x plus 2,529,000. This equation fits the plotted points very well with an r value over 0.98. This confirms that within the given range, the relationship between the given points is indeed linear, and we can interpolate any point within our data to come to a fairly accurate finding. When the demand variable y is set to the production capacity of 300,000 units, then we can solve for our price variable x. This yields an x value of $189 per unit. From the data given and assumptions made, this is the highest price that can be charged to veterinarians for oxyglobin, while maximizing the production potential of BioPure's factory. Using the calculated value of $189 per unit and considering the variable cost, the break-even point for oxyglobin is 191,131 units, representing $36,123,853 in revenue. After this point, BioPure will be generating a profit. At their current production capacity, they will make a profit on the next 108,869 units and generate an EBIT of $14,240,065.
The previous calculation assumed that oxyglobin would be introduced to veterinarians through distributors. The cost given for new product distribution is 30% of the price of the product being introduced. This results in an expense of $17,010,000 to sell 300,000 units of oxyglobin. Once oxyglobin is an established product in the veterinary market, the cost of distribution drops to 20% of the price of the product. This results in an expense of $11,340,000 to sell 300,000 units of oxyglobin. Another option for distribution of oxyglobin is to hire an in-house sales force. This was estimated to cost between $10 and $15 per unit. At the worst case scenario of $15 per unit, the cost to distribute 300,000 units of oxyglobin will be $4.5 million. With Hemopure being used on thousands of cats and dogs, BioPure will be able to monitor for any effect that may not have shown up during the FDA approval process. If any effects were to appear during the initial runs of oxyglobin, BioPure will be able to evaluate and remedy them before the release of their human product, avoiding future hardship. The years of production will allow the factory operations to evaluate their process and hone in their machinery to increase efficiency. This should drop the variable cost per unit and increase the profit margin on Hemopure when it does enter the market. Previous slides have shown that oxyglobin is projected to generate a profit for BioPure. This profit can be used by BioPure in many ways for the benefit of Hemopure. Some ways include expansion of production capacity and additional marketing funding. Also, generating a profit will make the IPO for BioPure more attractive and allow the company to raise more capital. When Hemopure is approved by the FDA, there will be a strong push within BioPure to get this high profit margin product to the market. Without accurate demand versus price values similar to those provided with the veterinary market, we are left to pick a target market and make an assumption. The market that best utilizes Hemopure's product differentiation of a 2-year shelf life and being non-temperature dependent is on-site trauma delivery. The vision would be to have units of Hemopure in every ambulance, fire truck, and police car for the immediate infusion into a patient before being transported to the hospital. This market consists of 500,000 cases, and assuming that each case only uses a single unit of blood, 500,000 units of blood required. We are making the conservative assumption that BioPure can capture 10% of that market. This would result in a requirement for BioPure to create 50,000 units of Hemopure. Since it takes twice as much time to produce a unit of Hemopure as it does to produce oxyglobin, this 50,000 unit increase in Hemopure results in a 100,000 unit decrease in oxyglobin. With oxyglobin at a demand of 200,000 units, the linear equation previously discussed yields a value of $198 per unit. When both products at the stated prices and quantities are evaluated, the break-even point becomes 25,856 units of Hemopure and 103,423 units of oxyglobin. This leaves BioPure making a profit on 24,144 units of Hemopure and 96,577 units of oxyglobin, resulting in an EBIT of $23,345,000. This is up 64% from just the production and sale of oxyglobin. One of the main concerns is how BioPure will be able to justify the high price tag of a human product and a significantly lower price tag of a veterinary product. Since Hemopure takes twice the production time of oxyglobin, doubling the price to about $400 is easy justification. To get from about $400 to into the $600 and $800 value is a little more difficult to prove with hard facts. The costs associated with the additional FDA testing would need to be recovered and can be included, and the demand for a product in life-saving trauma situations would make it less price sensitive. Hypothetically, the infusion of Hemopure product on site would benefit the patient and result in less complications at a later time. This reduction in complications would in turn result in lower total costs to insurance companies and reduce their pressure on the cost of Hemopure.
To arrive at a solution, we took into consideration all of the facts and circumstances surrounding BioPure's options and then assessed opportunities and threats while weighing their financial situation and possible profitability. We have determined that due to the circumstances surrounding the timing of the FDA approval of the two products, BioPure should go to market with its animal blood substitute, oxyglobin, while anticipating the FDA approval of its human blood substitute, Hemopure. Distribution costs through established distributors at 30% of the selling price represents a large portion of the cost of goods sold, but our estimates of acquiring the resources to establish an in-house sales force that can service 15,000 accounts would be prohibitive. BioPure would benefit from utilizing the distributor's experienced sales force. By the second year, this cost should be reduced to 20%. Oxyglobin would be the first and only veterinary blood substitute product on the market, with FDA approval providing a very strong barrier to entry for new competitors. The introduction of oxyglobin to the market would help create excitement about the company and boost the IPO. Oxyglobin sales and revenue generated by the IPO will help fund R&D to increase production capacity for Hemopure in the future. BioPure would realize R&D benefits from continued monitoring of oxyglobin's performance in small animals. BioPure will also gain product launch experience and can better determine the best branding for Hemopure. Considering that BioPure has only enough capital to support its operations for 2 years, the successful launch of oxyglobin will sustain operations while anticipating FDA approval of Hemopure. The situation also dictates that BioPure will need to invest in R&D that seek ways to increase its production capacity prior to the FDA approval of Hemopure to prevent a tug-of-war over production runs. We use a conservative estimate based on the survey data to predict oxyglobin demand. Assuming maximum production capacity and taking into consideration operating expenses, raw materials, and distribution fees, we calculated expected earnings before interest and taxes. Considering that the price per unit cost to veterinary practices determines demand, we recommend a price of $189 per unit. This will maximize BioPure's revenue and increase the probability of balancing supply and demand. This will also allow BioPure to invest or otherwise utilize the $50 million of venture capital. The sum total of the facts and circumstances, opportunities versus threats, financial situation, and profitability lead to the conclusion that BioPure should go to market. To successfully go to market with oxyglobin, a pre-launch and production plan are necessary. The pre-launch has 4 phases that include submitting the packaging, pricing, and demand forecast to the marketing director for approval, submitting the packaging policy to the FDA for approval, finalizing branding and labeling, and gearing up for production to ensure manufacturing requirements are in place. The production phase involves communicating the product's availability, benefits, and costs, and providing informative pamphlets and promotional material to distribution channels. This allows the distribution channels to educate veterinary practices and promote sales.
The high fixed costs and moderate to low variable costs of the oxyglobin product create the potential for high profits and moderate to high losses. Under existing cost structures, launching at $189 per unit will result in a 56% return on investment. BioPure will win the risk-return ratio analysis and will sustain its first mover advantage and firmly establish the company's brand.
Another prominent risk is the inability to obtain approval for Hemopure. Although the company will depend on oxyglobin, its profits will sustain company operations absent the ability to sell Hemopure. Furthermore, there is sufficient demand projections to allow BioPure to further gain customers within the veterinary market, provided, of course, additional production capacity can be acquired. When released, there may be risk associated with the price differential between the oxyglobin and Hemopure products. Remedies to this risk include ensuring Hemopure is competitively priced within the human market. In addition, focusing marketing messages on the difference between the markets and stressing the overall importance of blood substitutes as lifesavers, regardless of the life that is saved, human or animal.
There are risks associated with demand not materializing as anticipated, or oxyglobin is priced too high to generate sufficient demand. Analysis demonstrated that BioPure's maximum production capability is below both projected demand and current usage. Furthermore, analysis demonstrates successful profitability at $175 per unit. Price reductions can occur and still meet break-even obligations, although this will entail an additional 15,000 units that will need to be sold at the lower price.
Current production capabilities limit the amount of product that can be produced. In order to ensure sufficient market share when both products are being produced, assuming future FDA approval of Hemopure, of course, additional production facilities will be needed. One solution is to utilize profits garnered from the sale of oxyglobin to develop enhanced production capabilities.
The last risk analyzed was the potential for variable costs to increase. In order to mitigate these risks, potential solutions include working to establish long-term deals with cattle ranchers and lock in current pricing, the long-term potential to purchase a cattle ranch to directly control the production inputs, and the maintenance of an internal sales force rather than dependent on a distribution channel.
Thank you for listening to our presentation.